But our goal, you could actually make small changes to the molecule, and it would very easily turn from a kappa to a mu opioid receptor agonist. And that's actually how basically all of our standard opioids work, like morphine and oxycodone and stuff like that. So we were still kind of hitting the same receptor, but we were also looking at something a little bit more complex, something called biased signaling. And so what this means for those of you who don't know, when you activate a receptor, it has a typical signaling cascade that it does. But you can actually activate multiple things. And when you activate it in different ways, you can actually bias it towards one path or another. And so we think that one pathway is more associated with the addiction side of the opioids. And we think that the other pathway is more associated with the pain relief side. And so we were trying to essentially make compounds that were more biased to the pathway that would be for pain relief than the pathway for drug addiction.
That is super fascinating. Wow.
Yeah.
Wow. So you can actually try to nudge these opioid compounds to try to provide more pain relief and less addictive potential. Yeah.
And for anyone who's in science who kind of will understand these terms, one of the pathways is a beta-arrestin pathway, and the other pathway is a CAMP pathway, which is another common cell signaling pathway.
Yeah, it's involved in a lot of stuff. I did a little bit of studying on the CAMP pathway for looking at autophagy involved in that. That's super, super cool. That's honestly something that I think I've come across that concept of biosignaling a long time ago. Never thought about it again, probably since I came across it in college, and never thought about it in that context. That is super cool. And you're able to flip. So what changes to the molecule did you make to Salvinorin A to make that flip in the type of opioid receptor that it would target?
So there's an acetyl group on there, and we would essentially just attach or switch it out for a phenyl group, and that would essentially get us from kappa to mu. Now, the work that I was doing was essentially modifying a different part of the molecule, but part of the lab has been working with this molecule for years and years. So they had modified different functional groups just about everywhere on the molecule.